So Emily has a lot of concern.
Yes, I bet.
We're on a next year.
You said, you know, it's a very flexible structure, and I see what you mean.
Gotta be sure we understand.
And it's super visually engaging.
Yeah, I
There's
do.
definitely
I
one
do.
of the other ones.
My
Like,
work.
I
Yeah.
see it, but I
Yeah.
share it too.
Yeah. I was curious that if you, what does that look like?
Yes,
Okay. Do you have the USB? Because apparently
at the bottom of it.
it's not. Like connected to your laptop, maybe.
I forget it, you'll know.
It's easy for the can.
Oh, no. I don't wanna.
Do you have any audio or video? Okay. All right, you're all set there. Sure.
Thank you so much, Liz. That was.
Quick, I was. And now. So. Fascinating.
Thanks. Try to always do like at least one before, and that way I can. Thank you, though.
Gotta play
Carl and she owns do storytelling. That's beautiful. I haven't been there personally, but I've seen it.
Yeah, I saved you too.
Well, I should know.
Lady Gray, which is like my favorite, and nobody ever has Lady Gray. They always have Earl Grey.
Yeah.
Super smart people. Where did you say that you worked? Oh, okay. Yeah, so, do you know where Urbana-Champaign is at, or Springfield's at, in Illinois? We're about an hour out of Springfield, and then, an hour further would be Champaign. We've got Illinois State University there, and then, is there, as well as, yeah. Industry town. College town. Yeah. So, right now, because there's all moving in and out, and then it started these that are
Yeah,
just rental college kids. It's weird, it's Bloomington normal, it's like cities, but governments are separate, so so it's just a lot of like okay, yeah.
Hi, so I'm from 307 and, I'm institute for this, service.
So cool. So we have placed us some work in our area. Not really leads exactly, but facilitates. On it, and so it's really great to see sort of collaboration on the effort. So many strong.
While we're waiting, normally my presentations are to teachers, so this is going to be interesting today because I know people come from all different backgrounds. Where's everybody coming from, and what are the types of things that you do?
I'm an education coordinator at a small environmental nonprofit in the Bloomington Normal area of Illinois, so like an hour out of Springfield.
Excellent. Very good. Fantastic. We had a program a couple of years ago, that was sponsored through that was basically sending scientists out to churches throughout Indiana. And, it was very interesting because they sort of reframed climate change as creation care, which I had not heard before. You do what? Oh, very cool. Love it.
Thanks, Ashley. And I work for Indiana Conservation Voters, Senior Development Manager.
I just met you, but you might as well let other people know what you're doing here.
I'm Sean Mia. I'm with the City of Bloomington. I'm the Assistant Director of Sustainability, and I'm also an adjunct professor for Indiana University School of Public Health. I teach a class on Introduction to Climate Change and Health.
You have to be careful because this program has a lot of gravity. It's going to pull you right in, and you'll be our next facilitator. Awesome.
Yeah, my name is Madison. I work for Tippecanoe County, which is Lafayette, West Lafayette. Sure. And I'm an environmental educator for the recycling program, and I also work for a local nonprofit for Wabash River Education.
Oh, fantastic.
Like a split position, so you say, but
Good, good. Well, we bring a lot of people, not a lot, but we do have some people coming from the area down to our program. So very good.
I'm Madeline Schmidt. I'm the Sustainability Program Specialist for the City of So specifically, I work in our Climate Action Adaptation Plan that we have recently adopted, and then our Energy and Water Tracking Program, Outreach and Engagement, and Food Security.
Love it. Excellent. So you sort of,
All the things.
yeah, it was all the things. Right. Yeah. So, Rob.
Hi, Robert Green with the Most Policy Initiative. I'm just here to learn more about.
Oh, love it. Thank you, Robert.
faculty with a capillary.
Oh, very good, cool.
Hi, Julie Lindemann at Butler University, Assistant Director of Operational Sustainability at the Office of Sustainability.
I love it.
So, a long-winded answer.
But I feel like there's lots of, like, all of our universities here in Indiana all have some sustainability components to them. We have a lot of outreach efforts that are going on, but we don't seem to be coordinating them very well. And so maybe we can talk later about how we might be able to connect. I think that's great. Yeah.
So I'm Maggie McCoy. I'm the Climate Change Education Coordinator at Missouri Botanical Garden in St. Louis.
Awesome. Very good. Yeah, it's a beautiful place, by the way. Yeah.
I'm Kat Golden. I'm the Senior Manager for Sustainability Initiatives at the Botanical Garden. So some of our programs include K-12 school programs, as well as educating teachers. And then I also teach a course with Webster University in Education for Sustainability for existing and pre-service teachers.
Awesome. Well, good, because you're my prime audience then, because I will tell you that this presentation was primarily put together for National Science Teachers Association, Hoosier Association of Science Teachers, and that's really who I've given this in the past too. And I'm going to take you through basically the same thing that I do with them. So are we all set?
Yes, so one thing that's very helpful, our feeling
On that platform there.
microphone, especially helpful.
So you want me closer to this? Can I move this over here?
You can take it off that stand. and
All
hold it.
right, that's official.
Thank you.
Do I need to turn it on? Check. Okay, I can do that. Very good. So we're going to go ahead and get started. Are we on time? Close to it. All right. My name is Adam Scribner. I'm the Director of STEM Education Initiatives in the School of Education at Indiana University. I'm the Principal Investigator of a program called Educating for Environmental Change. Before we get started, if you want to just take a quick look at this, you can check out our website. And I'll put this back up again towards the end of the workshop. But you can sort of see all the types of programs that we run for Educating for Environmental Change through this QR code. So I'll give it a second. But of course, I want you paying attention too. So looking at it the whole time. All right. So today I have a very lofty agenda. I'm going to try to get through 3 things that might take an hour on their own, but I'm going to do them all within an hour. So it's ambitious, but I'm going to give it my best shot. The first thing I'm going to do is introduce you to Educating for Environmental Change, how you might be able to get involved in it. Second thing I'm going to do is an exemplar lesson about addressing student misconceptions and surfacing student thinking when it comes to climate change. And then the third thing that I'm going to do is how do we know the climate is changing? Sort of an exemplar activity that we do with our teachers. And then, of course, they go out and do these same things with their students. So what is Educating for Environmental Change? It is a program that we put together to help teachers teach the science and policy of climate change. That's what we're trying to do. And we have now worked with 400 teachers. We have worked with 20 different scientists. That'll be 21 when you join, scientists at Indiana University. And so we've sort of created this professional learning community here in Indiana. And beyond that, actually, we work with teachers outside of Indiana as well, teaching climate change. So I think a lot of teachers need a little bit of support to do this. And oftentimes, if they're teaching climate change in their school, they might be the only person that is doing that. So we're providing a professional learning community to those teachers. So what are our goals? Well, the first thing is to help teachers overcome misinformation, disinformation in the media and things that are out there. We want to improve teacher practices and effectiveness, teaching environmental change. And then, of course, provide teachers with direct access to IU's climate scientists. And I'll start there. When we first put this program together, we were thinking, oh, this is going to be so great. K-12 teachers are going to benefit immensely by working with these IU scientists. But the truth of the matter is that there's a lot of bidirectional benefits that are happening. Our scientists are really greatly benefiting by learning new ways to communicate their science to broader audiences. If you can teach it to a middle schooler, you can teach it to anybody, right? And that's the truth. So it's really been effective for all the people involved. So why did this program start? Maybe you've seen this book before. How many of you have seen this book before? Why Scientists Disagree About Global Warming. This book came out in about 2015, 2016. It was produced by the Heartland Institute. It was sent out to 350,000 teachers across the United States. If you are not a classroom science teacher, you probably don't have this book. if you were a classroom science teacher at that time, you probably do have this book. And the frightening thing about this book is that when scientists did a survey on the teachers who received the book, they said, oh, it's great that I have it because now it'll help me teach, quote, both sides of the issue. We all know, if we're in this room, that there are not two sides to this issue, right? That there is a clear consensus among scientists that climate change is happening and that humans are causing it. And so it's really important that teachers feel that they have the resources, that they have the support to teach climate change in the classroom. So this program was a direct result of that book being sent out. One thing that I like to say too, a lot of people have this idea that, especially here in the Midwest, that there is not support for teaching climate change. There is absolutely plenty of support for teaching climate change in the classroom here. 72% of Hoosiers and 79% of Americans agree that schools should be teaching children about the causes, consequences, and potential solutions to climate change. So it's a higher number than I think a lot of people think it is, but it still is a number that creates enough barriers where teachers don't teach it. And when you ask Americans in general, is the climate warming? So we're not talking about what's causing it, but is the climate warming? This map sort of shows that, yeah, across the United States, more than 50% of people, doesn't matter where you live, believes that the climate is warming. So that's a good place for us to start when we talk to others about climate change. And you can sort of see, it's kind of interesting to look at this map because you can sort of see areas where there's a higher percentage, little pockets throughout the Midwest. I also like to point out the National Science Teachers Association position paper on teaching climate change, just to provide a little bit more support. I'm not going to go through the whole thing here because there's a lot, but I'll get right down to the bottom and I'll read that. The NSTA confirms the solid scientific foundation on which climate change science rests and advocates for quality evidence-based science to be taught in science classrooms in grades K-12 and higher education. So there's a lot of support, not just in popular support, but of course for teachers to be teaching climate change. One of the main drivers for teachers to teach climate change is the standards themselves. Are the standards that the teachers have to teach explicit about climate change? There was a study in 2010 that basically says that science teachers have stated that state education standards are one of the main reasons for teaching climate change. So what do the standards look like in your state for teaching climate change? What do they look like in Indiana? I'm going to talk a little bit about that. A few years ago in 2020, the National Center for Science Education did a study where they had scientists look at each state's standards and graded each state based on the standards and how they would teach climate change. Have you guys seen that study before? You've seen the study? It's a really important study. And what was interesting about it, of course, is that Indiana, you would expect back in 2020, got a D. They were graded as a D for their science standards and how they would teach climate change. Myself and my colleagues from Educating for Environmental Change wrote an op-ed to the Indy Star that basically said, hey, look, this is not about politics. We just don't have good standards. And those can be rewritten and those can be changed. And we did change those. And that's something that I'm extremely proud of. And the Educating for Environmental Change team, the scientists and the teachers were really a part of the rewriting of the standards here in Indiana. So let's talk about those standards for a second. This is what an old standard in Indiana looked like. Research global temperatures over the past century, compare and contrast data in relation to the theory of climate change. So let's talk about two things, right? We're only looking at data for 100 years, past century. And then we're talking about climate change. Second thing is that as a scientist, I'm okay with the word theory, but nowhere else in the standards at the time did it use the word theory. So it wasn't the theory of gravity. It wasn't the theory of evolution. The only place where the word theory was in the standards in 2020 was in the theory of climate change. So this was important language, and it was something that we felt really needed to be changed. Let's contrast this, by the way, with the next generation science standards. So, which, by the way, have been adopted by Kentucky. They've been adopted by, I think, Illinois. Illinois is also an adopter, right? And they've been adopted by about 27 states across the United States. So the next generation science standards are, which, by the way, earned a B+ in
that National Center for Science Education study. They talk about the rise of global temperatures. They talk about human activity causing these changes. And they were also explicit about the word climate change, language that many states chose to leave out. But I also want to point out that there were some very, very conservative states, Montana, Alaska, again, Kentucky, that in that same National Center for Science Education study received these are better. So it's not about politics. We can write standards that teach kids about the causes and consequences of climate change. And it doesn't have to be about politics. So here's the new Indiana standard, something I'm really proud of. That same middle school standard that talked about the theory of climate change now says this: ask questions, clarify evidence, the factors that have caused the rise in global temperatures over time. And more importantly, we now have clarification statements for this. What does that actually mean? And how should teachers teach it? So really important stuff that's been changed in our standards. So the Educating for Environmental Change team, again, what I love about this team is that these are scientists that not only care about their science, but care immensely about how their science is communicated. So our team is made up of people from the Department of Earth and Atmospheric Sciences, biology, physics, from the Environmental Resilience Institute, which is, I think, one of the main drivers for the summit here today. The Center for Rural Engagement, the School of Education. We also have people from our Wonder Lab Museum, which is local to Bloomington. And we have a lot of veteran science teachers. And what we do is we look at the science that's happening at Indiana University. And then we pair the scientists up with local K-12 teachers to co-design lessons and activities for high school, middle school, and elementary school. So this is not lessons. We don't just take lessons that the scientists go, oh, this has really worked great with my graduate students, right? We take lessons and we try to modify them in a way that is grade level appropriate, age appropriate for students. And that's important. And again, they're co-designed by the teachers. So it's not just me and it's not just a bunch of scientists. These are K-12 teachers that get funded to work with the scientists to co-design lessons. So our team, again, this picture is not updated. We now are up to about 20 scientists at Indiana University that are affiliated with the program. If you want to see the whole list of them, if you go to the website, you can check it out. But we have people, again, from physics, from biology, from chemistry now, from Earth and Atmospheric Science, and all other departments, including the School of Public and Environmental Affairs. All right, what are our driving questions? Well, we have 4 main driving questions that all of the programs that we have fall under. The questions are, how do we know the climate is changing? What are the impacts of those changes? What must be done to mitigate the severity of the impacts of the changes? And then, of course, this one's really important. And we didn't have this question until the last couple of years. But this question might be the most important question. And how do we cultivate optimism in our students despite all of these things? So, of course, the main topic is climate change. But those topics, climate change is sort of the umbrella topic for lots of other topics as well, right? So we also talk about changes in biogeochemical cycles, degradation of soil and water quality, invasive species, and of course, how we can create better policy and engineer solutions to climate change. So there's lots of different science that's happening at Indiana University. And again, we want to translate that to the K-12 classroom. Or if I know a few of you work in the informal education spaces, we want to translate that to the informal education space as well, which is why we're also working with Wonder Lab. So what are some of the activities that we do? I'm going to take you through one in a little bit, but just a broad overview, measuring soil respiration, sampling tree cores, investigating ice cores, science lessons like changes in natural disasters, how much carbon do trees capture? We talk about advocacy in the classroom. Where does carbon come from? And we do lots of different labs, both in the field and in the classroom itself. And we also have started to introduce the teachers to our graduate students who are also doing environmental science and trying to help the graduate students communicate their science better as well. So oftentimes we will have poster sessions for our graduate students where K-12 teachers come and provide their own expertise to the graduate students. A few years ago, I think it was 2020, we realized that one of the biggest missing pieces of this program was that we have a lot of elementary school students that don't have the basic practices of science coming into middle schools and high schools. A lot of that has to do with the fact that, look, if you're an elementary school teacher, you have to deal with the curriculum bullies of mathematics and literacy, right? And they are the curriculum bullies. They get pushed out of other things. But there's an old saying, literacy is a domain in search of content, right? So what we try to get these elementary school teachers to do is to teach literacy through environmental change. And so we've provided lots of different children's books that they can use and things like that. But we've also started running elementary workshops for these teachers to try to get their students outside to learn the practices of science and lay the foundation for understanding environmental change. So we do lots of different activities and run just single one-day workshops, sometimes 2 or 3 day workshops for elementary school teachers specifically. So we do 3 things. We run summer science institutes, which can run anywhere from 3 days to 5 days in the summer. We run Saturday workshops, and we run what we call First Tuesday events. And by the way, we didn't used to run Saturday workshops, but if you're working with K-12 teachers, it's really important to meet them where they're at and to meet the schools where they're at. We used to run workshops during the week, provide stipends, as well as provided funding for substitutes for the teachers. But the bottom line is that a lot of teachers couldn't come during the week because there are no subs. So we had to start running these workshops on Saturdays. If you're working with K-12 teachers right now, if you want to do that work, you have to be able to provide Saturday workshops today because there are no substitutes. I actually had a $100,000 grant that I'm working with a local school district right now. And even with all the funding that was provided through that grant, they couldn't run the workshops for teachers in the middle of the week. We had to run it on weekends and provide the teachers with stipends for because there's just no subs. So anyway, we run Saturday workshops. The last few Saturday workshops were on these topics: birds, biodiversity, and environmental change. The one that's coming up in a couple of weeks, hill slopes, rivers, and bedrock, teaching environmental change in the field. We ran a workshop on geoengineering. In fact, we just wrote a National Science Foundation grant to teach climate engineering to students based on these workshops. Climate modeling, climate justice, disinformation, and integrating media literacy into instruction. And then, of course, that other driving question that I keep talking about, which is nurturing climate optimism through creativity. So we also run these First Tuesday programs. And what happened was that the science teachers were like, hey, we really like these workshops and these are great. It'd be really cool if we have like shorter workshops that we could come to in the evenings. So we set up these First Tuesday programs. And what these are is typically a scientist will introduce their science for about an hour. And then the last half hour, we talk about how we might translate that back into the classroom. So they're an hour and a half long. They're the first Tuesday of every month. And the last few that we've had, Cultivating Climate Champions, a dynamic approach to teaching climate change across subjects. That was in March. Then we did just this past Tuesday, a couple days ago, 4 minutes in April, a solar eclipse in Indiana. Had to be time, right? We had to do the solar eclipse thing. But it's really cool, actually, all of the natural phenomena that's going to be associated with that solar eclipse, like how it's going to impact bird species and temperature changes and all the other things that are happening. And then our next one is one of the professors of physics, Professor Emeritus of Physics, is going to be doing one, came up with a unique title, Showers, Bananas, and Climate Change, Our Climate from Several Viewpoints. So that's going to be May 7th. Some of these are online, so if you are out of state, you can always join them. Any teacher that comes to them gets a $25 gift card for their time. And so that's kind of a nice thing. And then, of course, anybody that comes, any of the teachers that come to our Saturday workshops get $150 stipends for their time. A lot of times, I can tell you that when I first started this program, I had to push to get those stipends, right? Because I remember our first amount of funding came from internal IU funds. And they were like, well, wait a minute, you're giving the teachers breakfast and lunch. Do you really need to get them stipends? Yes, you do. It's really important. These people are professionals. They're giving up their Saturdays to improve their practice. It's important that we do that. And so fortunately, our funders understand that and have been very generous. So just really quickly by the numbers, we work with about 160 teachers a year, impacting over 14,000 students. The things that I'm most proud of is that 100% of the participating teachers agree that their understanding of climate change has increased, that their understanding of how humans are causing climate change has increased, and that they expect to apply what they learned in class. Because that's really the most important thing, right? We know that if you run a workshop with a group of teachers and you don't provide any follow-up support, in other words, you're not sending out emails that say, hey, have you tried this out yet? Have you done these things? Only about 15% of teachers will adopt and apply what they've learned. This is a study that comes from Joyce and Showers from 2002. But if you follow up with them, if you're constantly reminding them about the program, if you're sending follow-up support, if you're offering to bring the scientists into their classroom via Zoom or in person, that increases adoption and application. It's really important that we do that. So this last part of I expect to apply what I learned in my class, just because they expect to doesn't mean that they always do. So following up with the teachers is imperative, right? And one of the teacher evaluations had this to say, this workshop has been mind-blowing, overwhelming in a good way, and exciting. It has absolutely given me the confidence to teach climate change. So something I'm really, really proud of. And one final note in this sort of the small print. In 2020, we did win the Governor's Award for extraordinary initiatives for protecting the environment, which in this state is kind of a big deal. And the project is supported by the Environmental Resilience Institute, Indiana University's Prepare for Environmental Change Grand Challenge Initiative, the IU Center for Rural Engagement, the Brabson Family Foundation, and 2 anonymous foundations. And my hope is that this will soon be funded by the National Science Foundation as well. So we're getting there and we're building momentum. The other thing I want to say to all of you who work in a nonprofit and you write grants to do this work, which you're shaking your head, yes, this is tough work, right? I've been doing this now for 13 years. When I first started this project, I initially wrote a grant for $200,000. It was funded at about $65,000. And the amount of my time, instead of being 20% of my time, was cut down to 2.5% of my time. But to get this project off the ground, it was really 20%, right? That's the hard work. Once you get it going, once you get these things off the ground, they build momentum. And now that we have 19, 20 scientists involved, and their names are on the grants that are going in, these are the types of things. And this is how you get the ball rolling. But sometimes, and we have any administrators in this room, it's really important that you understand too, that start small and you have to build it, right? And that means that programs like this need internal support to get things off the ground. It's not always going to start with an NSF grant. 9 times out of 10, usually does. So just wanted to mention that. All right. Again, if you have not checked out our website, you can do this, and I'll put this up at the end as well. But you can see all of those First Tuesday programs, all of those Saturday workshops, as well as our Summer Science Institute. You can watch a little video on the Summer Science Institute as well. All right. And you can see all the past workshops that we've run also. Okay. Are there any questions about that? Yes.
I know you said the personal contact is really important, but have you found any way to archive some of the curricula so they can be used by other teachers that don't have that one relationship?
100%. Yes. So we are actually putting together a full curriculum based on all of the things that we've done. We hope if you go to our website right now and you go to the Summer Science Institute section, you can click on resources. And right now it's just like a giant 50-page Google Doc that you can see all of our lessons and activities. We put them up there for free. I'm not a fan of teachers pay teachers. I'm a big fan of in education, we need to be collegial and share our lessons and activities that we develop. And so we do that. And we're hoping that we're going to make that a little bit more professional than just a Google Doc. I actually have some graduate students working on that right now. So, yeah.
Have to be in Indiana.
No, 100%. No. In fact, in 2020 and 2021, we ran the Summer Science Institutes online, and we had people from all over the world participate in it. A lot of people ask me, how do you choose who comes to the workshops? I usually do first come, first serve. Like if you're a teacher that wants to come to this program, by all means come, And so that's really what I do. Once we get to if I have 25 spaces, once we get to 25 people signed up, I usually cut it off. And so if people are coming from out of state, come. I think it'd be great. And in fact, any way that we can sort of spread our work, then we're good with that. It used to be that a lot of our funding stated that we needed to work with Indiana teachers, but our current funding does not. And so we don't have to do that. In fact, myself and one of my colleagues was down in the Galapagos Islands a couple months ago, and we were doing work, basically working with schools down there. And the reason why we're doing that is to connect the schools down there to the schools here in Indiana. And we're going to be bringing 2 teachers from the Galapagos Islands up to the Summer Science Institute this year, so they can learn from each other, because the Galapagos Islands it's really important that the students learn that the decisions they're making here are impacting places like that. Okay. So I'll provide more time for questions at the end. So we're going to now do an exemplar lesson on addressing student misconceptions and surfacing student thinking. And so let's talk about misconceptions for a second. This is a video, and I think this PowerPoint's going to be made available to you. I'm not going to show the video right now because it's about 7 minutes long, but it's a really great video. When I teach science education courses at Indiana University, I always start with this video, and it's 50 common misconceptions in science. And I'll just give you some examples. So elementary school teachers are really known for teaching the fact that we have 5 senses, right? There's lots more than 5 senses, right? Those are the 5 traditional senses, but there's lots more. Like we have hunger, we have thirst, we have proprioception, we have balance. So there's lots of them. Another common misconception that's out there is the Brontosaurus. Did you know that the Brontosaurus never even existed, right? The Brontosaurus was the head of an Apatosaurus and the body of a Camarasaurus. That's first, remember, but it never existed. But all of my childhood was learning about Brontosaurus. Brontosauri? Yes. Anyway, so there's lots of misconceptions. And where we pick up those misconceptions is really important. And there are lots of misconceptions about our climate, right? So let's talk about that for a second. One of my favorite misconceptions stories actually comes from the Annenberg Foundation. Annenberg Foundation is famous for doing a video called A Private Universe. If you work in science education, you've probably seen this. It's where a bunch of graduates from Harvard University and MIT, they go up to them and they ask them basic science questions. Most of them are like hungover and, they're still going up to them and asking them, and then, and they say like, why do we have seasons? And some of the students go, because sometimes we're closer to the sun, sometimes we're farther, and ignoring the tilt of the Earth's axis and things like that. In the Annenberg video, in that same Private Universe video, they did something pretty interesting. They took like a 5th grade student and they placed an apple in it. And they said, how do you see this apple? And the student said, I got this. I look at the apple and energy shoots out of my eyeballs and it hits the apple. And then it comes back into my brain. Brain figures it out. Whoa, that's interesting. Could you draw that for me? Right? So surfacing student thinking, having students draw their thoughts, right? And so he drew like a stick figure, and then he drew like lightning bolts, like Harry Potter shooting right out of his eyeballs and hitting the apple. And they said, that is amazing. How did you come up with that idea? And he goes, oh, I like to watch a lot of shows about nature. And they said, well, in particular? And he said, yep, sometimes I like to watch shows about bats. And so you're all sitting there shaking your head and you're going, now I understand how the student came up with that idea of how he sees. That student did what in science education is the holy grail, right? He transferred the knowledge of what he saw, probably a model of echolocation, and said, if that works for sound and bats, that must be how my eyes work with light. You never know where students are going to come up with misconceptions. What we do know is that all of us have science misconceptions. And so how do we address them? And so I want to talk a little bit about that. One of the things that we provide to the teachers that come to Educating for Environmental Change are these books. How many of you have seen these books before? These are called Uncovering Student Ideas books. Oh, good. I always love when I get to show these people. And by the way, I do not get a cut of these books. So these books are written by a colleague. Her name is Paige Keeley. And Paige Keeley, if there's a Mount Rushmore of science education, I would put Paige Keeley's face right on it. Because what she did is she said, what are the misconceptions that students have in science? And how can we create simple formative assessment probes to learn about those misconceptions and address them? So let me show you what one of these probes looks like. So here's one called The Coldest Winter Ever. And if we are going to teach students about climate change, then they better know the difference between climate and weather. Many of our politicians do not. So it's important that we teach our kids, right? So here's what the probe looks like. It's pretty simple. It's just a worksheet that looks like this, right? And again, these probes are based on the misconceptions that students have. So here's what it says in the probe. Mr. and Mrs. Martin were watching the news one evening in January. The news anchor announced that Florida was experiencing one of the coldest winters ever recorded in the state. The temperature even dropped to a low of 32 degrees in Miami. It snowed in some parts of Florida. Mr. and Mrs. Martin looked at each other and said, Mr. Martin, wow, that is the biggest change in our weather. Mrs. Martin, wow, that is the biggest change in our climate. So, what would students say? Who would they agree with most and why? And so these simple formative assessment probes, you can see, like you could have written this, right? Paige Keeley looked at the research and wrote these probes in a very simple way that you could use with elementary school kids, middle school kids, and high school kids. So, what's the answer? Is this a change in weather or a change in climate? Or what would students say? What's that? Yeah, a lot of students would say that. In fact, the research tells us, and this is the research that Paige Keeley used to write this probe, 80% of middle school and high school students thought it was true or mostly true that climate changes from year to year. Folks, 80%. So any education outreach program has to start with addressing this misconception first, or we're going to have a tough time teaching climate change to kids, right? So teaching about climate change starts with addressing student misconceptions and surfacing their thinking about these things. All right. A very similar probe that's also in this book is what is a watershed? The reason why I added this today is because I was working with one of the professors in Department of Earth and Atmospheric Science, and he, for what happened was that during the pandemic, he decided that his students should be working with K-12 teachers because they needed to do something online. And so they started writing K-12 lesson plans, which I thought was a really cool idea, right? And I showed them this probe. And so here's what the probe looks like. Again, very similar to what the other probe is. 5 friends were talking about watersheds. Each had different ideas about a watershed. I'm not going to read these to you, but you get the idea. All of these probes kind of look the same. It's where one student thinks one thing, another student thinks another, and these are all based, all of the distractor answers to the correct answer are all based on the research of what the misconceptions are, right? Why would students, by the way, think that a watershed is something that's human-made? It has the word shed in it. Sheds are human-made, right? So of course they have that misconception. Other misconceptions that this probe is based on is the idea that watersheds don't happen in urban areas, right? Watersheds don't happen below the ground. They only happen on the surface. So all of these misconceptions are built into this probe. And whenever a student picks one that's one of the ones that's not correct, it lets the educator know that this is a misconception that I need to address. So that's why these books are so good. And the good thing is she's done all the work for you. You don't have to do them. And it's one of the reasons why we share these books with our teachers. And so again, one of the cool things too is that these Uncovering Student Ideas book, it doesn't matter if you're teaching biology or chemistry, physics, there's a book for each topic. This is the one for Earth and Atmospheric Science, but there's lots of others as well. There's even Uncovering Student Ideas books for mathematics. So these are really, really great. Oh, by the way, so the research that informed that probe about watersheds, let's just take a look at this. One of the studies from 2005 found that some students thought watersheds as towers or well houses, which is exactly what you said, that it was a human-made object. 41% of adults surveyed basically had no idea of what a watershed is. 41% of adults. This is the reason why when I lived in New York City, and I did for 17 years, I saw a person one time pouring paint down a water well, right? Because they just assumed it went to a water treatment plant, not out to the Hudson River, right? So it's really important that we, again, address student misconceptions and that we surface their thinking about it. Okay, so again, these Uncovering Student Ideas books are really, really great. If you're doing education outreach, this might be a good place to start with just about any topic that you're teaching. All right. One thing that I do want to say about this, though, is that a lot of times teachers will get these books and they will just use them as worksheets. I saw this on Twitter, and I thought this was pretty funny, that I did some calculations. If you do too many worksheets, of course, wonder goes down. So it's important that we don't just use them as worksheets, but there's lots of suggestions in these books about how you can use these probes as do-nows, as conversation starters, lots of different ways that you can use them, not just as worksheets. All right. That's part 2. Part 3, our last and final lesson. How do we know that climate is changing? So let's talk about this. So how do we know?
Spring is 2 months, or summer is 4 months, and fall is a month, winter is 5 months. We can realize that climate is changing.
Yeah, so we sort of see changes in our temperatures, right, over periods of time, long periods of time. By the way, getting back to that question of what is the difference between climate and weather, there's not an exact number that we can put on that. Most scientists agree that it's 30 or more years of a weather change. But I work with other people in Earth and atmospheric science that would argue that it could be shorter than that, a little bit longer than that. So there's no perfect number. But I think for our purposes in education, 30 years. So yeah, we see changes in our weather. What else do we see changes?
I'm in churches. I usually tell the armadillo story in Missouri.
Oh, go on.
The first time did you ever see an armadillo in Missouri? And then they start to think back and they're like, and so I ask them questions like, what happened when you were little with an older group? The younger group's like, oh, that's not supposed to be there. So the animal changes.
Oh, it changes in animals, changes in animal migrations, for sure. Very good. What else?
The same note as animals, changes in plants. I mean, invasive plants are well right now. I think everywhere you go, there's some sort of plant that's increasing biodiversity and taking over our ecosystems, which obviously has impacts on soil erosion and I don't know, a lot of things.
Perfect. Flora and fauna. What else? Yeah. Yeah, we can look at our oceans for sure. Anything else? Precipitation changes, comes with changes in weather for sure. Yeah. Yeah.
Composition and ice pouring.
Yes, yes. We can look at ice on the planet. Very good. Anything else?
Wildfire smoke.
Yeah. So we can look at changes in natural disasters and disasters. Yeah. Very good. So basically, there's a lot of essential climate variables. Again, we can look at our atmosphere. We can look at changes on land, which includes those ice caps and glaciers, and we can look at changes in oceans, like sea level rise. Very good. So today, what we're going to do is we're going to look at ice caps and ice sheets. And to do that, we're going to look specifically at ice cores. So one of the activities that we do with our teachers is an ice core lesson. And I want to do that with you now. So first of all, let me show you an ice core. Have to be unmiked for this, so I'll just talk a little bit louder. I have a model ice core here. What do you notice about it? What do you see? When I do this with teachers and students, I'll usually give every group of 4 one of these. We'll take a look at them. So let's talk about this. Let's not talk about what you see. Let's talk about what students would see. So let's talk about middle school students or high school students. What would they notice about this? Coloration. So we might see some changes in colors. What else do you think they would notice? Striation. So they would see layers. Very good. What else? Sort of see some browns and some clears. And you can even see some areas that are more clear than others. Very good. What else? Yeah, so you can sort of see some cloudy, as you say, ice and some clear ice, which might be able sort of let us know that there's a change in maybe chemical composition or the way that these I guess layers came together may have been a little bit different, right? Very good. So we do this with our teachers. This is one of the first lessons. And again, this falls under that driving questions of how do we know that the climate is changing, right? And so we do this with model ice cores. And so really quickly, let's take a look at some other model ice cores that we work with. Does anybody, by the way, do this activity? Take this level. Does anybody do this activity? This is a great first activity to get students thinking again about how we know that the climate is changing. And you can do these model ice cores pretty simply. And you might notice that with this one, you can see some other things in there. Sometimes you can put rocks. Sometimes you can see some greenish. So there might be some plants that are near the ice, things like that. There's lots of different ways that you can make these. So what is causing these changes in layers? Let's talk about the layers first. What do the layers represent? Yeah, so how the ice forms over time. So what's happening to create those layers? That's right. So it's just a change in precipitation. And it could be a seasonal change or it could be an annual change, right? That's causing it. So we can look at each layer as a season or look at each layer as a year. And that's what causes this. And so each layer represents a certain amount of precipitation that gets packed down, and then another layer and another layer and another layer. That's how these layers form. What about the changes in colors? What do you think is causing those? Yeah. So, right. So these are what scientists call reference horizons. It could be from a volcanic eruption. It could be from a dust cloud. All of these different things will create these distinct layers. And the reason why they're called reference horizons, if we know when Mount St. Helens, for instance, erupted, then we know that that layer came from 1980, I think it was, right? So it can help the scientists determine the age of these layers. And that's really important. Right? Using models is really, really important in science education. It's a practice that's very important. And of course, we have the students make inferences as well as make observations. So what do we notice? We notice that the layers are caused by snow accumulations in the polar regions. We notice that the colors, which can be made by, again, dust or volcanic ash in the atmosphere. And we also notice that there's lots of bubbles in there. And so we can do some chemistry on those bubbles to determine what the atmosphere was like and also use it as a proxy for understanding what the temperatures were like over periods of time. So, by the way that I made this model ice core, kind of simple. You basically just put the Pringle can into a freezer and you add little layers over periods of time. This took me about, I think I started this 2 days ago. And I just, every time I walked past the freezer, I would open it up and add another layer. And the way I made the darker layers, the reference horizons, I just added a little tea or a little coffee to the water before I poured it in. If you're working with elementary school students, you can add little rocks to it. But if you do that, be very, very careful. Do not put the ice core in your disposal or down in your sink that has a disposal. I ruined my disposal because I threw my ice cores in the sink and then I turned on the disposal later and there were rocks there. Don't do that. But you can also put little plastic insects in there. You can put all kinds of things. The more stuff you put in there, obviously, the more observations the students can make. And of course, the more inferences they can make about the model itself. All right. So let's talk about this. What is in ice cores? There's lots of stuff. First of all, there's air bubbles that can tell us how much carbon dioxide, how much methane, how much greenhouse gases were in the atmosphere at the time that the layer was made. You can do the chemistry on this, determine the isotopes, which helps us understand the temperatures at the time. And of course, these reference horizons that I already talked about, which are basically these distinct layers that are caused by volcanic activity or dust fluxes. All right. So then what we do is after we have the students make the observations and inferences about the ice cores, and by the way, that's where it stops with elementary school kids. We don't actually take them to this next step. But when I work with middle school kids, high school kids, or my college students, I then take them to this step where we talk about the fact that we have real life data that comes from real ice cores, both from the Arctic and the Antarctic. Our Antarctic ice cores go back 800,000 years. Arctic ice cores are not that old. This one is a Vostok ice core. It was 3,350 meters long, and we're going to take a look at that data right now. So let's take a look at it. When I do this with students, I basically have two driving questions for it. How has the Earth's climate changed over time? And how has the trend of change fluctuated in the recent past? So let's take a look. If we're looking at the Vostok ice core, first of all, how many years does this go back? Just looking at, can you guys see this okay? Okay, I hope all the people on Zoom can see this all right as well. How far back does this go in time? 425,000 years, right? And what was the average temperature? What was the fluctuation of average temperature? What was the highest temperatures that we see? And this is in Celsius. About 3, right? So the highest point is about 3 degrees Celsius. What's the lowest point? What's that? Yeah, about -9. And what do we notice here? Does anybody know what we would call these periods compared to these periods? What do you think the Earth was like when we were down at -9? Oh, sorry. When we're down here. Yeah, so these are different ice ages. So one of the things that's really important by showing these data to students is that they can see that the Earth has gone through lots of natural cycles. And of course, you can talk about what causes this, right? The sun-Earth-Moon relationship, the wobble in the Earth's axis, all of that stuff. But it's really important that they recognize that there are natural cycles to the Earth, right? We call these cycles interglacial periods, and we call these down cycles glacial periods. Does that make sense? Yeah, pretty simple. And so you could have the students go, okay, well, we've seen 1, 2, 3, 4, 5 interglacial periods and 1, 2, 3, 4 glacial periods over the last 450,000 years. It's really important that students notice that. All right. But one thing that we want to talk about, highest temperature was about 3 degrees Celsius. Lowest temperature is about -9. I'm doing on time. Oh, crud, I got 10 minutes. All right, here we go. So, and by the way, we use lots of sample prompts with our students and give these to our teachers as well, like where is present time on the graph? How far back does the record go? All that stuff. All right. So now what we're going to do is we're going to zoom in on just the last 165,000 years. And again, what we're looking at here is we can see up here this sort of interglacial period and another interglacial period. And we can see that the temperatures may be about 1 degree centigrade, and our lowest point's about -6 or -7 down here. All right. So this is for the last 165,000 years. I want you to take a close look at this, put it in your brain, and now we're going to look. So this is the temperature. Now we're going to look at carbon dioxide over that same period of time. So here's CO2 over the same period of time. What would students notice about these two graphs back to back? Temperature, CO2. Temperature, CO2. Yeah, of course. And of course, one of the things that's really important that we talk about in science education is that correlation is not always causation, right? But we get the students to see that there's a strong correlation between increase in CO2 and increase in temperature over the last 165,000 years. All right. And one of the things too is that we want students to recognize that the highest point for CO2 parts per million, by the way, it's something important to talk to our students about, right? 280 parts per million. That means if you have 1 million ping pong balls, only 280 of them are going to be CO2. How does that impact? How does that make such a difference in our atmosphere, right? And so that drives the next question. This is what inquiry science is all about. Now the students go, why does CO2 do that, right? But if you're pointing these things out right, they're going to raise the question and that's that. You don't have to. Okay, so we're up to, and so again, we see about 280 parts per million is at the high, and down here, about 180 parts per million for the last 165,000 years. If we combine this with Antarctic ice core data, we can go back even further. We can go back 800,000 years, right? And what we notice is that the highest CO2 levels over 800,000 years is about 300 parts per million. The lowest, about 180 parts per million for 300,000 years. 180, 300. What's our CO2 level today? 400? Anybody else? Come on, don't be shy. I was a classroom teacher for 13 years. I have a long wait time. Come on, what else? 350? So this is what's called the Keeling curve. The Keeling curve is very famous. Keeling, I think when he first started taking CO2 measurements in Hawaii, he was doing it. He was actually working I think he was working on ways to increase nuclear power there. But he created a measurement tool that started measuring CO2 levels. And I don't think he ever expected that this would become one of the most famous graphs in the world. But this is now called the Keeling curve. This is CO2 levels. Oh, sorry. This is CO2 levels over time. You can sort of see it's slowly going up. Why does it rise and fall here, by the way? What's happening that causes this rise and fall each year? Go ahead. Yeah, seasons. It's basically the deciduous trees, right? Our trees take in certain amounts of carbon dioxide. When they lose their leaves, they don't take in as much, right? So we can see that the CO2 levels has increased. Now, again, for 800,000 years, the highest CO2 level was about 300 parts per million. Our CO2 level today, this was just the other day, 424 parts per million. So we are continuously going up. And of course, this has to do with fossil fuels, right? Burning of fossil fuels is what's causing this to continue to rise over years. And when students hear this, they start recognizing that, okay, this is what's causing these changes in temperatures. This is what's causing these changes to our climate over periods of time. But of course, if you teach this to students, and that's one of the first things that we teach. So the first thing we do is we talk about the difference between weather and climate. And then, of course, we go right into these ice core activities. These are really important first lessons to get them to understand climate change. But let's not forget that last driving question. How do we cultivate optimism in the face of this? So I've got 6 minutes left. This is really important. So how do we do this? First of all, I like to set up most of our programs based on climate change in 10 words. How many of you have seen this before? Okay. Yeah, so this is a great way to teach climate change. If you're ever going to be putting together a whole unit on climate change or lessons on climate change, you can do it just based on these 10 words. You start off with the fact that, like we just did, it's real. This would be the ice core lesson, right? This would be the misconception about weather and climate. The next one, it's us. How do we know that humans are causing this? Not that this is just part of the natural cycle, right? It's bad. What are the impacts? And how is it impacting, right? We run entire workshops on climate justice. Climate justice is a lens that we use to teach this. Who's being impacted the most? It's really important that we do that, right? Scientists agree. How do we know that? And then the last part, there's hope. So how do we teach there's hope to our students? I think that there's something that we need to talk about that we don't talk about enough. When I was a kid, I was a child of the 80s. I figured I was going to die one of two ways. And by the way, when I taught science, I used to joke a little bit about this, but I think there was some truth to it. When I was a science teacher, I used to say that my class was 20 ways we're going to die, right? I talked about pandemics. I talked about hurricanes. I talked about floods. I talked about climate change. I talked about all of it. But I never really engaged our students in how they could be part of the process. There's a big miss on my as an educator back then. And it's one of the things that if I were to go back in the classroom, it's one of the things I would change. But when I was a kid, I figured I was going to die one of two ways. If you're a child of the 80s, you know this, right? You are going to die because of nuclear war and nuclear fallout, right? Because if you grew up in the 80s, you grew up with movies like Red Dawn and Wolverine, like that whole thing. So we were going to die of nuclear fallout. The other way that I was going to die was there was a hole in the ozone layer that every year that I was a kid got bigger and bigger and bigger. And I remember seeing the NASA images of the hole in the ozone layer. And I remember thinking, this is it. By the time I'm 40, we're all going to have cancer. And honestly, I thought that would be the end. But what happened? Why are we all sitting here right now? None of us are in this room? We're talking about climate change, but we're not talking about the hole in the ozone layer. Why is that? Because in 1989, every country got together and signed an agreement that said they were going to stop using the chlorofluorocarbons that were causing the ozone layer to deplete. And they signed an agreement, like the Paris Agreement. They signed an agreement that they followed up and did what they said they were going to do. We don't tell that story, right? There is a cause for optimism. There is a historical precedent for cooperation internationally to change our world for the better. And it's the Montreal Protocol. Every single country, I think it was 280 countries, all signed it and then did what they said they were going to. That's the reason why we're all sitting here right now, not worried about skin cancer by walking outside. But this is a story that I think should be told more often. The other thing that I do with our students, I have 3 whole minutes left. All right, the other thing that I do, how many of you have seen this before? Yes, very good. This is called the En-ROADS simulator. This is really cool. I do this with middle school and high school students, or I should say middle school and high school teachers who then do this with their students. And what you can do with this is basically, this takes all the data. This was created by MIT. This takes all of the current data that's out there. If you just Google En-ROADS, you can find this, the simulator. And what students can do is they can say, okay, I've heard that if we electrify all of our cars, and we electrify all of our transportation, that we are going to solve the climate crisis. And so you can go, okay, let's test that out. And what's interesting, if they go here to this En-ROADS simulator and they move this all the way here, where we change it from the status quo to highly incentivized reductions in or I should say increases in electrification in our transportation. You know what's interesting? When you do that, this graph doesn't change a lot. I think it goes down to like 3.5 or 3.4. Not a big change. But if we do that and we move our coal energy supplies way down and our oil energy supplies way down, and we increase maybe nuclear, we increase a carbon tax, whatever, then we see these massive changes. But the cool thing is that we can take these arguments that students hear about, and then they can actually put it to the test, and they can change, and they can see real time what those changes will do. And what En-ROADS is trying to do is they're trying to get students to come up with the best solutions for our planet, right? If you are working with high school students, you can click on these little 3 buttons, and you can actually turn this from qualitative to quantitative, so you can actually see how much changes that you want to make, the amount of changes. Pretty interesting stuff. So those are 2 ways that we talk about there's hope, but there's many more as well. And so if you want to come to any educating for environmental change programs. So with that, are there any final questions about our programs? Yeah.
High school health teachers and to start a curriculum about climate change and health.
We have done workshops on climate change and human health, but we have not worked with high school health teachers. Most of our outreach is to science teachers, but we've been sort of branching out more to English teachers and social studies teachers, basically anybody that teaches climate change. We also have like a couple of elementary school teachers that come to all of our high school programs, you know, because they find ways to adapt it to their classrooms. So yeah, we're open to anyone and everyone that wants to come and do this. And by the way, I don't discriminate in this project as well. If you are if you're working in churches, or you're working in a museum, or you're working in different nonprofits, and you want to come to our programs, come. We'd love to have you. So our programs are open to everybody. Any other questions?
Conversations about getting like pre-K involved and stuff like this, starting them very young. I know like we get a lot of pre-K groups asking us for presentations and ways to integrate that in.
Yeah, for sure. I mean, one of the things that we do, I think the most important thing that we do when we work with, and we do have some pre-K teachers that come, but not many, but we have a lot of kindergarten teachers that come. when we work with them, we really just try to emphasize getting the students outside, making observations in nature, things like that. It's not about teaching climate change. This is much more about just providing them with the foundations to understand those practices of a scientist. And so we do a lot of work with that. Yeah.
You spoke earlier about your struggle to fight like that need to do math and to do kind of literacy before or you get to all of this. But like in my work, it has been like putting up the air monitors to like look at graphs and use those type of math skills with the science, like with the action. So I didn't know if there was ways that you're trying to fight that.
So one of the things that's really important and we talk to the teachers a lot about is that you can't just throw data at people that are skeptical or don't believe in climate change. So what's really important is that we provide two things, right? Both the data, like we just did, but also you have to do what her researcher's name is, but she calls them evidence-weighted narratives, stories. You have to tell those stories too. You have to tell the story of the farmer in Indiana that didn't believe in climate change, but now has had 3 100-year floods in the last 10 years and has lost 20% of their crops. Those stories have to be told in addition to mathematics. I think that that's really important, but I don't know if I answered your question. Did I answer your question? Oh, say it.
To talk more about like how to
to integrate. Yeah. So obviously when we work with elementary school teachers, they really want to make sure that we integrate literacy as well. And so we use a lot of books. Sometimes they're global books or children's books to sort of introduce these topics. So the literacy component's there. And then of course, when we do programs like Life in a Square, we integrate mathematics. The percentage of the square that is soil compared to plants. So we try to come up with ways to integrate those things because we know that teachers, they need to see that there are these connections to literacy and mathematics if they're going to integrate it into their elementary school classroom. Yeah, so good question. Any other questions? Yes.
Yes,
Yeah, I'm sorry. Yeah, my whole childhood was when I first heard that, it sort of threw me for a loop. And in fact, I was at Liberty Science Center, which is outside of New York City, just a few years ago, and they still had like a model of the brontosaurus. And I'm like, I need to talk to the science educator there. Yeah, because yeah, there's lots of misconceptions. If you've never seen that 50 science misconceptions video, it's really cool. It's a great way to start any sort of conversation about science with people and just let them know we all have these misconceptions. Let's all start there. Yeah. Any other questions? Oh, well, thank you so much for coming out and learning about educating for environmental change. If you, again, go back to the, do I have it on here? Okay. I'll go back to the QR code and you can check out our website. You can see all the
Invitation will be out there.
It will. And this is like, you're just reliving it. And okay, so, but if you go to this QR code, you can check out the Educating for Environmental Change website. You can see all of our opportunities. Please come. We're happy to have teachers and non-teachers alike. If you work in the communities, we'd love to have you. I think it's really great what you're all doing. The fact that you're here tells me that you're interested in working in education. And really, look, we know that working with teachers is the best way to reach people. Because if I run a summer camp for 24 kids, I'll reach 24 kids. But if I work with 24 teachers, I'm going to work with 2,400 kids every single year that those teachers adopt and apply what they learn. So working with teachers is really, really a great way to get the word out and help people understand climate change. It's really good. All right. Thanks, everyone.
Box lunches are now being served lower level academies for dietaries. There's the and set aside, and then all of these all day are set aside for us for lunch. There's plenty of places around the campus center to find a place. These are nice, quiet areas. If there's someone who you're looking to meet up with, specifically in this room and the room next door, having a climate cafe, which is if you want to join conversations about some of the emotions related to climate change, climate anxiety, the hope that comes with it. That's a conversation happening in 305, and here there's someone presenting on carbon capturing and statistics. So if you're more interested in the scientific academic conversation, that'll be happening in this room. Otherwise, find somewhere to hang out and enjoy your lunch.
By the way, if you do this, this ice core thing, these ice cores will last for an entire day. So if you, like, I know that a lot of people are like, oh, won't it just melt? This thing will go for all day. So if you're running this with multiple classes, you just need one ice core, few ice cores.
Are you actually the two people?
Really,
Yeah, no, that's great. Again. So, thank you very much. But yeah, it's awesome. So
yeah, I think.
that is our two affiliate 16 states, just yeah,
Sessions.
interesting.
So. That summarize it.
No, I get you. Yeah, we're fully remote, and like I said, I get it. And you know, even though we're like local to Indiana, kind of just there's some great red state, and we don't have kind of resources like that. And we're trying to figure it out, and we have such a
Yeah, I missed it as well.
are really stuff. So we're trying to know that, and just the and you know, and trying to stay like